On router number 1, I want to filter all 40 prefixes. I want to filter all 40 prefixes on router number 1. Can I achieve my task through standard ACL? Through standard ACL? I want to filter all 40 network on router number 1, right? From both neighbor. So is it possible through a standard ACL? Can I use a standard access control list to filter these prefixes?
Uh, Possibly can, I guess.
So tell me then why? How? How? Sorry.
Because everything is into different subnets, right? So we can.
So I can match only this network 10 40.1.0.0. All prefixes will come under this prefix na, this network na. So if I will filter this one, this network, all 40 prefixes will be filtered on router number 1.
No, that's it. If you're using that filter, right, then probably maybe if it is no slash 20, 2 or 21, something like that, then everything will come. But in that case, in the ACL, we have to define in such a way that small subnets we have to do, or else, then as
Yeah,
yesterday
I
you
am
told
asking
us,
you
right?
if I want to filter all these prefixes on router number 1. Can I achieve my task through standard ACL? Answer is yes or no.
Yes.
Yes.
Yes, I think we can use by using that command yesterday you shown from
Yes.
greater than 24 slash
No,
and
that
less
is
than.
that is let's say I want to filter prefixes whose length is
Yes,
between
No,
26
that
to
is using
28.
prefix length.
I am not
yes,
talking
yes, yes,
about prefix length now. Just I am asking you if I want to filter all prefixes, all 40 prefixes,
yes,
whose
yes, we can.
last value is
Yeah, we
24,
can.
25,
We can.
27. If I can, then how? How I will create one access list? Access list number 10. Then what action I will define here? Permit or deny?
Permit.
No, you are going to deny now these
Yes,
prefixes. So you will
yes.
create
Restrict
access
Deny,
access.
control
deny.
list with deny statement. And after that subnet. So subnet can be 40.1.0.0, right? Or I can say 40.0.0.0 also. If I will deny this network, then also all 40 prefixes will deny. If I will deny 40.1.0.0, then also all 40 prefixes will denied. And if I will say 40.1.0, this network, if I am denying this network, only first network 40.1.1.0 slash 24 network will deny, right? So I want to deny all. So 40.1.0.0, and after that wildcard 10.0.255.255. Then as you know, here implicit deny is enabled by default, so we need to create one access control list with permit statement for all other traffic. So access list number again same, permit any, right? After that, how I will apply this access control list? What is the command? Router
EIG.
EIGRP 10 and then distribute list.
Distribution data.
Distribute. Yeah.
Distribute list, access list number, and in which direction you want to apply this access control list, right? So in direction means I want to filter the prefixes when R1 will receive from their neighbor. That's it. Now after some time, if I will check routing table of R1, we will not see any 40 prefixes. All 40 prefixes is filtered from router number 1, right? Do so IP route EIGRP. See, all 40 prefixes are filtered from the routing table of R1, correct? Now I am going to remove this filtering. Now tell me, I want to filter these all prefixes again. I have removed this command and I am removing access list also, no access list number 10. This time I want to filter again all 40 prefixes, but from the neighbor router 2 only. I want to receive these all prefixes from router number 3, but I don't want to receive any 40 prefixes from router number 2. Can I achieve this task through a standard ACL? This time I want to filter all 40 prefixes from a particular neighbor. Can I achieve this task through a standard ACL?
Yeah, extended ACL can, with the source you have to mention, right?
A standard ACL. In a standard ACL, we cannot define source. In extended ACL, we can.
Yeah, in extended ACL only.
So it is not possible with the help of extended ACL. So here we have to use extended ACL because this time I am interested to define source also. So I will create extended ACL access list number 101 and then deny 40.1.0.0 wildcard mask 0.0.255.255.255 and then deny IP protocol and then 40.1.0.0 wildcard mask 0.0.255. What happened here?
One more 255.
1 0 is missing in the net
Yes.
mask. One more.
Where? 0 is not missing. Destination. Okay, so here it is asking for source. So source is what? I want to filter 40 prefixes from router number 2. So source will be IP address of router 2
FA0
10.1.1.
slash 0.
FA0/0 of router 2, right? Let me check what is the
Yeah,
IP
that
address there.
interface IP.
So IP interface brief exclude unassign. Here IP address is 10.2. So source is going to be 10.2 wildcard mask 0.0.0 and destination 40.1.0.0 wildcard mask 0.0.255.255. Correct? Then access list with permit statement permit IP any. Now we will apply this access control list in EAGRP. So router EAGRP number 10 distribute list access list number 101 direction in. Soon EAGRP neighbors you will resynchronize and then you will see 40 prefixes is filtered from router number 2. Do so IP route EAGRP. It is receiving all 40 prefixes from one neighbor only, right? From router number 3. See, next hop is 10.1.1.3. Fine. So this is filtering with the help of extended ACL. I am going to remove this also. Okay, say no to this and after that no access control list 101. Okay, now again router 1 will receive all prefixes from both neighbors. So IP route EAGRP and now you can see again it is performing load balancing. Router 1 is performing load balancing. Now this time I want to filter prefixes whose length is from 26 to 28, let's say. So can I achieve this task with the help of extended ACL or standard ACL? See, I want to filter the prefixes whose length is starting from 26 and let's say ending with /28. Between these two slash value I want to filter all prefixes and including these two also, like whose prefix length is greater than and equal to 26 and less than and equal to 28. Can I achieve this task with the help of ACL access control list? Answer is no. This is not possible with the help of access control list. Then whenever we need to filter prefixes with prefix length, then we have different feature, that is prefix list. Here we need to use prefix list feature to filter these prefixes. Now how we will apply it? Again, like ACL, you will create one prefix list, command is IP prefix list, the name of prefix list. After that, after the network and wildcard mask. So here you see on router number 1 how I can create it. I have removed the access control list. Do so access list. Yeah, we don't have any access control list here. So I am going to create one prefix list here, IP prefix list, the name of prefix list, let's say CCNA or CCNP. After that, deny or permit action. Or if you want to define the sequence number, you can define here sequence number also. Okay, if you will not define any sequence number, it will take what sequence number? 5. Fine. So I am going to say deny the network 40.1.0.0. In this network, all these prefixes are matching, right? After that, here slash value slash 16, and then greater than and equal to is, let's say, slash 25, and less than and equal to 28. So it will filter how many prefixes? 40.1.
4 prefixes.
2.0 or not? It will filter this prefix 40.1.2.0.
Yes.
Right. 3.0.
Yes.
4.0.
Yes.
5.0.
Yes.
Yes, it will filter these all prefixes. Then again we need to define one permit statement for REST traffic. So IP prefix list CCNP, then permit, and for any here we will use 0.0.0/0, or here we can say less than 32, means all traffic, all the prefixes whose length is less than /32. And now again I will use this prefix list in EIGRP. So router EIGRP number 10, and then distribute list, prefix list, name of prefix list is CCNP, and direction in. Again EIGRP neighbors will resynchronize, and then we will check the routing table of R1. Do so IP route EIGRP. See, all the prefixes whose length is from /25 to /28 are filtered from the routing table of router 1. Okay. Fine. So always keep in mind, whenever we need to filter prefixes with the help of prefix length, we will use prefix list. Whenever we need to filter prefixes from a specific source, we will use extended ACL. Whenever we need to filter only prefixes, doesn't matter source, right, or anything prefix length, we can use standard ACL. With the help of prefix list, we can filter prefixes by using prefix length. And sequence number gap in prefix list is 5. Fine. Is it clear? So I am going to remove this also. And no IP prefix list, no IP prefix list CCNP. Yes. So IP prefix list, we don't have any prefix list here. So IP access list, we don't have any access list here. And so IP protocol. So filtering is also not applied for in direction or out direction. For both direction, filtering is not set. Fine. Now the important filtering. See, the filtering which is not possible with the help of prefix list and access control list. Like on router number 1, show IP route EIGRP. So IP route EIGRP. Router 1 is receiving these prefixes from both sides. You can see it is performing again load balancing, and router 1 have many prefixes in their routing table like 34 network, 24 network, and all network have some metric value, if I want to filter prefixes with the help of metric, like I want to filter those prefixes whose metric is 327 30720. So when your requirement is like this, I want to filter prefixes with the help of metric, or many more options are there. Metric is one of them. Then we will use route map feature. Which feature? Route map. Okay, fine. Like here you can see on router number 1, so IP route EIGRP. I want to filter prefixes whose metric is this one. Simply I will create one route map, and creating route map is very easy. See, route map, you need to run this command route map. After that, name of route map, let's say CCNP, and then permit or deny action. So here I am going to say deny, and then you can define sequence number or you can ignore it also. Let me say sequence number 10, and now I am going to say match this metric, this value. Now it will match this metric value. What this route map will do, this route map will match all the prefixes with this metric. All the prefixes with this metric is interesting traffic for now. For us, traffic with this metric are interesting traffic, or is interesting traffic. Now I am going to call this route map in EIGRP again. Right, but before that I have created one route map with deny statement. So automatically rest traffic will deny, all other metric will also deny. So I have to create one more route map with permit statement. Again I will use same command route map, name is CCNP permit, and that's it. Then we can define again sequence number. Let's say sequence number is 11. And here if I will not match anything, like in this route map I have matched this metric. If you will not match anything, that means router will match all the things. Okay, so here I am going to exit. So in the permit statement we have matched all other traffic. Now router EIGRP is number 10, and distribute list. This time I am going to call route map. Name of route map is CCNP, and then direction in. That's it. Now EIGRP neighbors will resynchronize, and then you will see this metric is filtered. Prefixes with this metric is filtered. So IP route EIGRP. Are you able to see? 24 prefix and 34 prefix are filtered from the routing table of R1, because 24 and 34 network have this metric. Okay, how we can check it, how we can verify? We can verify it by running command show IP protocol. By running show IP protocol, I can see that route map is applied on in direction, and name of that route map is CCNP. Now I can check route map. So route map CCNP. See, in the route map we have matched this metric. Now if you want to remove it, you can remove it. Fine. And see, router EIGRP number 10. Guys, is it clear? Tell me. Is it clear to you? How we can filter prefixes with the help of route map? Let's say on router number 1. On router number 1 we have so IP route EAGRP. Only 40 prefixes, and these prefixes have this metric. So if I want to filter prefixes whose metric is this one, what I can do, again I can create route map, name CCNP, permit, and sequence number I am going to use 10. Say match this metric. Match metric, this one, sorry, here metric. Metric, this one. And so route map, let me check route map. Yes, now we are matching two metric values. So IP route EAGRP. Soon it will filter these prefixes also. So route map. Oh, I have created this time route map with permit statement. With permit statement, let me do one thing. No route map CCNP, and then route map CCNP deny, and the sequence number, let's say 10, then match metric, and where is the metric? This metric now. So let me copy the metric here and let me paste here. This metric, and then route map CCNP with permit statement, let's say sequence number 11. So route map, so see route map, in route map we have deny statement and we are matching this metric, and next route map is permitting all rest traffic. And on R1 if you will check routing table now, so IP route EAGRP, let me mute. So IP protocol route map CCNP is applied for incoming traffic, and so route map we are denying this metric. Permit sequence number 11, everything is fine, it should clear. IP EAGRP neighbor, so IP route EAGRP. Oh, these prefixes have different metric. I had copied metric from somewhere else, I think. Route map CCNP deny sequence number 10 match metric, this one. So route map correct. Now so IP route EAGRP. Wait for some time. Now you can see so IP route EAGRP. All 40 prefixes are filtered from router number 1. Okay, so is it clear guys how to filter prefixes with the help of route map? Please let me know so that I can move.
Sir, I have one one doubt in that prefix
List.
the previous one. Yeah,
Prefix list.
the subnet is. So there we can filter it only based on the prefix list, right? Either some range we can define greater than and less than.
Correct.
But in that same list, let's say if we wanted to no, restrict one prefix list from this source, maybe with this router 2, and the other thing with router 3, can we filter it in that way?
Okay, means some prefixes from
Yeah,
particular
this
source.
prefixes from this source only. This prefixes from this source only. So in that case, practically we can actually do the load sharing or something like that.
Okay, okay, like IP prefix list, CCNA. Deny 40.1.0.0/16 greater than or equal to 25, less than or equal to 26, let's say. No, here we cannot define source.
Okay, 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 sir. Yeah.
Any other question? Then what you can do, you can apply it prefix list on router number 2 or on router number 3, right? Means for the outbound traffic. When router 2 will advertise to router number 3 or router number 1, it will filter that one. Getting my point?
And in the same EAGRP, can we use both access list and the prefix list? In that case, maybe we can try that one. Huh?
No, what you said, please say again.
I mean, when we are configuring the AGRP, right? There we will call out that respective ACL or prefix list, right? So can
Yes,
we call out both? I'm asking. Is it
one
technically
in
possible?
one direction, one in
Yeah,
one
for
direction.
inbound, for inbound, yeah.
For one inbound, you can call to one only, not both.
Oh, okay, okay.
Okay. Any other question? So I'm expecting that route filtering with the help of route map is also clear to you. So I'm going to remove it. Say no distribute list route map CCNP direction in, and I'm going to remove route map also. Say no route map CCNP. Fine. So IP route EIGRP. Now again it is performing load balancing for these all prefixes. So this is guys all about filtering. This is all about filtering. In route map you have many more options also, like route map CCNP. Here you can match many other things also, like you can see the options. Here you can call to access control list also. We can match, these are the part of BGP. We can match interface also. On a particular interface, if you want to filter the prefixes, you can use this feature. Length, length of traffic.
Sir, can you explain about that local preference? Because
This is
practically
part of
we.
BGP. We'll discuss it in BGP.
Oh, okay, okay, fine.
Local preference is one attribute of BGP. Like in EIGRP, what are the attribute? Attribute is like K1, K3, bandwidth, relay. These are what? Attribute that EIGRP router used to calculate best path. Like this, BGP use local preference to calculate best path. Like this, there are many other attribute also, but this one is also one attribute to select best path. Okay, we'll discuss it in BGP. Then we can match metric value. We can match route type, like we'll discuss about this also, this feature also. We can use tag, like we can add some tag. Okay, we'll perform this lab here. Let's say router 4 is connected with one another router number 5, and router 5 have some prefixes. Let's say 10.1.1.0/24, and here we are running any other routing protocol. Let's say OSPF. and this router has one more router neighbor R6, and R6 have also some prefixes. Okay, and this is, let's say, RIP domain. Here we are running RIP routing protocol. So on R4 you will perform redistribution. You will advertise all the prefixes of OSPF domain in EIGRP, all the prefixes of RIP domain in EIGRP, right? And in EIGRP domain, if you want to separate the prefixes of OSPF and RIP, let's say this is one different department, sales department, and there are 100 prefixes. This is, let's say, HR department. In this department there are 50 prefixes. So in EIGRP domain, when you will receive these prefixes in EIGRP domain, how you will differentiate which prefixes coming from the sales department, or which prefixes are coming from the HR department, or from which department which prefix are coming, because all prefixes will have AD value 170 only. That means these are external prefixes, right? So but we can, with the help of this AD value, we can differentiate that this is external prefix, not internal prefix, but we cannot differentiate this is prefixes of sales or HR. So while redistribution, we can add tag value. We can add tag value. Let's say here I have add tag number 10 for sales prefixes and tag number 20 for HR prefixes. And with the help of this tag number, if you want to achieve filtering, route filtering, you can do that with the help of route map. So here you have option to use tag. Getting my point? We can discuss it in redistribution, like when we will redistribute external prefixes in EIGRP, we can add some tag value, or we can filter the prefixes with the help of tag, right? In BGP we will use, you know, you will use route map in most of the topic. In most of the topics we will use route map in BGP. There is lots of use in BGP. There's lot of use of route map in BGP. Fine. For now, should I start redistribution, guys? Because this is all about route filtering. Can I start redistribution now? Let me turn off this device. Stop all node. You all know basic redistribution, right? How to redistribute prefixes in EIGRP domain. Basic redistribution. We can perform basic redistribution in GNS3 also, GNS3. Otherwise here I can also create one lab, but the GNS3 is easy. Let me design one lab here. Let's say here I have router 1, router 2, router 3, router 4 and router 5. Let's say this is my EIGRP domain and this is any other routing protocol domain. Here we are running, let's say, OSPF. First let me connect this device. This is OSPF domain and this is, let's say, EAGRP domain. This is a small organization, right? Let's say we are connecting two different organizations together. So in this scenario, we have two options. Either I can change configuration on all routers. I can replace the EAGRP configuration from OSPF, because here we are running OSPF, or in OSPF domain we can change the configuration. But if I have lots of routers in OSPF domain and lots of routers are in EAGRP domain, we can redistribute the prefixes of each routing protocol in each domain instead of replacing the configuration on all routers, because it is difficult to configure all routers again. Fine. So how we will achieve it? On router number 4, we will redistribute OSPF prefixes in EAGRP domain and EAGRP prefixes in OSPF domain. Let's say here on router number 5 we have some prefix 50.1.1.0/24, 50.1.2.0/24, 50.1.3.0/24, and 50.1. Or let's say 50.1.3.0 is last network, right? In OSPF domain. In EAGRP domain also, let's say we have some prefix on router number 1, 10.1.1.0/24, 10.1.2.0/24, and 10.1.3.0/24. EAGRP. In EAGRP domain also we have some prefixes. So see, first of all, let me configure the scenario, then see the redistribution. First basic redistribution configuration, and then we will discuss about the advanced redistribution, like how to add tag number while redistribution, how we can achieve route filtering or path manipulation. Okay, so let me access this router first of all. It's better I am going to say this is my EAGRP domain and this is my OSPF domain. Configure T interface fast Ethernet 0/0, no shut. No shut, and IP address is 12.1.1.1, 255.255.255.0. Exit interface loopback 1. IP address is 10.1.1.1, 255.255.255.0. Interface loopback 2. IP address is 10.1.2.1. Interface loopback 3. IP address is 10.1.3.1. Then exit router EAGRP number 10, network 0.0.0. Done. Then router 2, interface fast Ethernet 0/0, no shut. IP address is 12.1.1.2, 255.255.255.0. Exit interface fast Ethernet 1/0, no shut. IP address is 23.1.1.2, 255.255.255.0. Exit router EAGRP number 10, network 0.0.0.0. Fine. Interface fast Ethernet 0/0, no shut. IP address is 23.1.1.3, 255.255.255.0. Exit interface fast Ethernet 1/0, no shut. IP address 34.1.1.3, 255.255.255.0. Exit router EAGRP number 10, network 0.0.0. Soon here also EAGRP University will come up. Yes, you can see. Then router 4, interface fast Ethernet 0/0, no shut. IP address 34.1.1.4, 255.255.255.0 exit, interface fast Ethernet 1/0, NOSUT, IP address 45.1.1.4, 255.255.255.0 exit, router EIGRP S number 10, network 0.0.0. Fine. Then router 5, interface fast Ethernet 0/0, NOSUT, IP, sorry. On
Sir, in
router number
router
3,
4 EHRP running, huh?
on router number 3, I have configured, I have advertised both interface in EIGRP, and on router 4 also. I am going to remove this configuration. No router 4, no router EIGRP S number 10. And on router number 3 also, I am going to remove 0.0.0 command, because 0.0.0 command will advertise both interface in EIGRP, but one interface of router 3 belongs to OSPF domain. So say no network 0.0.0, and then I am going to run network 23.1.1.3 0.0.0. Fine. Do so IP EIGRP neighbor. So router 3 have only one EIGRP neighbor, that is router 2. Fine. We don't have EIGRP neighbors between router 3 and router 4. Now on router number 3, as you know, we have one interface in OSPF domain, so we need to configure OSPF also. So router OSPF and process ID 1. We'll discuss about the OSPF configuration, don't worry. Router ID 1.1.1.1, and then network. Network is 34.1.1.3, 0.0.0.0, and area 0. This is OSPF configuration. Don't worry about this configuration. On R4, no, I have removed the EIGRP configuration. Router OSPF process 1 and router ID. Here I am going to say router ID, let's say 4.4.4.4, and network. Here I can run 0.0.0 also, but 34.1.1.4 is the best. Area 0 and network 45.1.1.4, 0.0.0, area 0. Soon OSPF neighborship will come up between router 3 and router 4. Do so IP OSPF neighbor. Yeah, so neighbor is in two-way state. Soon it will come in full state. Till then, let me configure R5. So on R5, fast Ethernet 0/0, IP address is 45.1.1.5, 255.255.255.0, and then we need to create some loopback here. Interface loopback 1, IP address is 50.1.1.1, 255.255.255.0. Interface loopback 2, IP address is 50.1.2.1. Interface loopback 3, IP address is 50.1.3.1. Fine. And then router OSPF process 1, router ID 5.5.5.5, exit, sorry, router OSPF process 1 and network 45.1.1.5, wildcard mask this one, and area 0, and then network 50.1.1.0, wildcard mask 0.0.255, area 0, and then this network 50.1.2.0, 50.1.3.0, 3.0. Fine. So IP OSPF neighbor. So neighborship is full here. And on router number 3, router 3 have one EIGRP neighbor and one OSPF neighbor. Let me show you. So IP EIGRP neighbor. So router 2 is EIGRP neighbor, and so IP OSPF neighbor. Router 4 means 4.4.4 is OSPF neighbor. Fine. So it will have two routing table. So IP route EIGRP. This is EIGRP routing table. In this routing table, you can see these prefixes. R1 is advertising these prefixes, and so IP route OSPF. In the OSPF routing table, you can see these all 50 prefixes. Fine. And in the global routing table, it will install both 10 prefixes as well as 50 prefixes. Correct? One second, guys. Okay. So in the global routing table, it have prefixes of EIGRP also, and it have prefixes of OSPF also. But on router number 1 or any other router like router number 1, so IP route EIGRP. In the EIGRP routing table, you can see only 23 network is there, right? And so IP route in global routing table also we are not able to see 50 prefixes, because router 3 is not advertising any prefix of OSPF in EIGRP domain, right? Router 3 is not advertising these 50 prefixes in EIGRP domain, right? Because till now we have not performed the redistribution. So router, until and unless you will not perform redistribution between two routing protocol, router is not going to exchange prefixes between routing domain. So here on router number 3 and on router number 5 also you can see, so IP route OSPF. In the OSPF routing table only 34 networks are there, right? And so IP routing table, in global routing table you can see there is no any 10 prefixes. Means again router 3 is not advertising any EIGRP prefixes in OSPF domain also, right? So on R3 we can say router EIGRPS number 10 and then redistribute, this command redistribute. Now if you will put question mark here, see it's asking for BGP. Do you want to redistribute BGP in EIGRP? Do you want to redistribute connected prefix, means directly connected network? Do you want to advertise redistribute EIGRP prefix, means different AS of EIGRP? Do you want to advertise ISIS? This one is not for you. OSPF, RIP, static or VRF. So for now I want to redistribute OSPF, yes or no? I want to redistribute OSPF. After that it is asking for OSPF process ID. So my OSPF process ID is 1. Process ID is 1. And if you will hit enter here, see, done. I have redistribute OSPF process 1 in EIGRP. Now let me check routing table of R3. See, in the routing table still 50 prefixes are not there. Why? Because metric calculation of EIGRP is different, metric calculation of OSPF is different. Now whenever EIGRP router will advertise OSPF prefix in EIGRP, you have to define K values like K1 and K3. What bandwidth it will use for metric calculation and what delay value it will use for metric calculation, right? Because these are redistributed prefix, not connected prefix, right? So that it can check the bandwidth and delay of interfaces, right? So on router number 3 this command will not work. I am going to say no to this, and then again redistribute OSPF process 1 and match what? Internal, this is different thing. Match, not match. Metric. And then bandwidth. What should be the bandwidth? Let me say bandwidth. Whenever you will redistribute OSPF prefix in EIGRP, use this value as a bandwidth. And what is delay? Use this 100 as a delay. What should be the reliability? 255. What should be the load? 100. MTU 1500 byte. So I have, see here I have provide all K values, all 5 types of K values, right? With the help of this, it can calculate matrix. And now if you will check the routing table of R1, you will see 50 prefixes. Now router 3 will redistribute OSPF prefix in EIGRP. Let me show you again the routing table of R1. Fine. And here you can see the AD value. AD value is 170. As I told you, EIGRP using 3 AD value. One is 90, one is 70, and one is 5. 90 for internal prefix, 170 for external prefix, and 5 for summary prefix. Clear? Fine. So IP route EIGRP. External prefix. These are external prefix. EX means external. It have received 34 also and 45 network also. 45.1.1.0. We are running this network between router 4 and router 5. In OSPF domain, how many prefixes are there? Can anyone tell me? In OSPF, how many prefixes are there?
5.
5, right?
5. And EIGRP domain? 5.
Same 5.
Correct. So we have how many external prefixes here on router number 1? 3, 4, 5. Now can I ping 50.1.1.1? Can I ping this IP address?
Yes, it should work.
Yeah, can, I guess.
Now ping is not working. Can anyone tell me the reason? Route is available in the routing table, but I'm not able to ping.
No, but reverse also,
Yeah,
OSPF also has to be redistributed, right?
exactly. Actually happening, what happening? See on router number 5, we don't have any prefix, any route for 10 network for source. Yes or no? So R5 is dropping. So reverse path is not available for now. Right, that's why router 1 is not able to ping 50.1.1.1. So now again on router number 3, what I need to do, router OSPF, this time router OSPF process ID 1, and in OSPF we are going to redistribute EIGRP S number 10, and you need to use one keyword, that is subnet. And finally, sorry, I have run this command on router number 5. I need to run it on router number 3. Right? So on router number 3, router OSPF 1 and redistribute EIGRP S number 10 subnets. That's it. Now let me take you to R5 here. Let me check the routing table of R5. So IP route OSPF. Yes, it is also receiving some external prefixes. In OSPF, we will understand external prefixes. There are two types of external prefixes, one with symbol E2 and one with symbol E1. We'll understand matrix type in OSPF. Don't worry. But these are external prefixes. See how many prefixes are there in EIGRP domain and how many prefixes are here in the routing table of R5. External prefixes. Okay. There's some prefix with symbol O. O stands for OSPF. OE2 stands for OSPF external matrix type 2. Fine. And now if you will ping will work. You can see ping is working. So this is basic redistribution. Like this you can redistribute RIP domain also. Let's say here I have one router connected with router number 3. Or what we can do here, let's say between router 2 and router 4, router 3 and router 4, I am running RIP also. Let's say here we have 2 link. Okay, between router 3 and router 4 we have two link like this, and on upper link we are running EIGRP, and router 4 have some prefix, let's say 40.1 dot, what happened to GNS3, 40.1.1.0 slash 24, 40.1.2.0 slash 24. Let's say router 2, router 4 have these two loopback. Now let me configure it. On router number 4, first of all let me configure one IP. On router number 3, interface fast ethernet 1/1, no set, and on this link I am going to use subnet, let's say 43, IP address 43.1.1.3, 255.255.255.0, and then router rip version 2, no auto summary, and network. Which network? 43.1.1.0. Fine. Now let me take you to R4. On R4, first let me create two loopback. Interface loopback 1. IP address is 40.1.1.1, 255.255.255.0. Loopback 2. IP address is 40.1.2.0. 2.0, and interface fast ethernet 1/1, no set, and here IP address is 43.1.1.4, 255.255.255.0, and now I'm going to run RIP routing protocol, router RIP, no auto summary, version 2, and network 43.1.1.0, and network 40.0.0.0, let's say. Done. So IP RIP database, it have installed these prefixes in their database 40.1.1.0 and 40.1.2.0, and we have configured RIP between router 3 router 4, so router 4 will advertise it to router number 3 also. So let me check. So IP route RIP, so yes, it have received these two prefix 40.1.1.0 and 40.1.2.0, but on router number 1 you will not see these two prefix. So IP route EIGRP 40 prefixes is not there, right? Why? Because we have not redistribute RIP in EIGRP, we have only redistribute OSPF in EIGRP. So now on router number 3 again we need to redistribute RIP in EIGRP, router EIGRPS number 10, router EIGRPS number 10, redistribute RIP, and then metric K1, this one K3, 100, reliability, load, MTU. Fine. And now on router number 1 we can check routing table again. You can see we are receiving some external prefixes from OSPF domain and some external prefixes from RIP domain. Like these two prefixes are coming from RIP domain and these prefixes are coming from OSPF domain, but here we cannot differentiate it, right? Both are look like similar, both have same AD value, right? And in the same way on router number 3 you will redistribute EIGRP into RIP. Like on router number 4 you can see, so IP router 4 is receiving 10 prefixes, all 10 prefixes, but through OSPF, not through RIP routing protocol, through OSPF, not through RIP routing protocol. Or so IP RIP database, we can check RIP database also. You can see in RIP database also we don't have 10 prefixes. So on R3 now we need to redistribute EIGRP into RIP routing protocol. So again on router number 3 this time I will run command router RIP, and here I will run redistribute EIGRP S number 10, and then how RIP routing protocol calculates metric? Hop count, right? So you have to define hop count here, metric, and then whatever hop count you want to set, You can set from 0 to 6. So if I will set here 5, and now if I will take you to R4 and let me check the RIP database again. So now you can see in the RIP database still we don't have these prefixes on R3. So run section EIGRP section router RIP, redistribute EIGRP as number 10, that is correct, metric 5. So it should advertise then. It have installed, yes, it have installed these prefixes in their database. See, router 3 have installed 10 prefixes in their database because we have performed the redistribution. But it is advertising to router number 4 also, but router 4 is taking time. Or this type of problem is there in GNS3. That's why I am performing most of the filtering task in EVNG. Like Dhana saying, when I am configuring hop count 3, my neighborship is flapping. When I am configuring hop count 10, it's working fine. Okay, so like this we can redistribute RIP into EIGRP, EIGRP into RIP, EIGRP into OSPF, and OSPF into EIGRP. But this is basic redistribution.
Sir,
Fine.
can you show the OSPF redistribution commands once? I missed that actually.
On router number 3, right?
Yeah, in R3.
So run section router OSPF. Inside the router OSPF, I have run this command. Here in OSPF, if you will not use this keyword subnets, it will advertise classful network only. So this is keyword in case of OSPF. And when we are redistributing EIGRP into RIP, then we need to define hop count. When we are advertising any prefixes in EIGRP, we need to define K values. And when we are advertising any routing protocol in OSPF, we need to use this keyword subnets. That's it. Very simple. Yes.
Okay, router OSPF1 and router ID. Okay. No, 1.1.1.1 is the router ID of R4.
Yeah, here I have configured 1.1.1 on router number 3. No
Oh, and
problem.
R3.
Yeah.
Oh, you are just no, because in EIGRP actually you told right. We will have to when we have to mention that K parameters also K1 to K5. So
That
similarly,
you want to see?
yeah, that's no that I know, sir. I mean that I saw. But in when you are redistributing OSPF, I missed that slide. That's why I wanted to just see what when while redistributing OSPF, just the OSPF command alone is enough, or any other parameter we need to redistribute.
No. That command is enough. No need to define any other
Okay.
things.
Okay.
Only subnets here we are using for classless network. Otherwise, it is nature of OSPF. You will understand in OSPF because in OSPF routers OSPF is completely different routing protocol as compared to EIGRP. Now in EIGRP router are exchanging routes directly. Yes or no? In the update message, it is sending the network information, but in case of OSPF you will see routers are exchanging database. So filtering is also different in case of OSPF. If you want to
Okay.
filter route in OSPF, you have to filter the database. So in OSPF we need to use subnets key, but you will understand this also. You will understand this also in OSPF videos. Don't worry.
Okay, sir. Thank you.
Any other question? Now let me discuss now advanced redistribution. Let me close this lab. And in this diagram you can see we have EIGRP, we have RIP, we have OSPF. For now you only need to understand the redistribution of OSPF in EIGRP. Don't worry about OSPF configuration or anything about OSPF what I am doing. You will understand OSPF later when I will start OSPF series. For now we are just filtering prefixes of, I am going to filter the prefixes of OSPF here in EIGRP domain, or I am going to differentiate the prefixes between RIP and OSPF in EIGRP domain. That's why I am using OSPF here. I will configure only. Okay, so router number 7 have some prefixes like 70.1.1.0/24 to 70.1.5.0/24. Router 5 have also some prefixes, and router 1 have also some prefixes. I think EIGRP is already running, and RIP, OSPF, I think routing protocols is already running here. Let me check once the configuration. Otherwise, I have to configure everything again. So IP route EIGRP. Yes, EIGRP is running here, right? So run section EIGRP. Fine. And so IP route, let me check, am I receiving external prefixes? No, I'm not receiving any external prefixes here. That means redistribution, we need to configure redistribution on router number 3. I'm not going to access R2 because I think R2 configuration is done. Here EIGRP is running. That's why here you can see, so IP EIGRP neighbor 12.1.1.2 is neighbor. Directly I'm going to access router 3. On router 3, enable so IP route EIGRP. Yes, it is receiving these all 10 prefixes. So IP route RIP. Yes, it is receiving all 50 prefixes here, all 50 prefixes, these prefixes. And so IP route OSPF, it is receiving all 70 prefixes in OSPF also, you can see. So configuration is done here. On router number 1, see one more thing in EIGRP. If you don't want to define k values every time, like whenever you redistribute any other prefixes in EIGRP, you don't want to define k values every time. So you can configure one default k values also, like router will use that k values every time. Okay, now on router number 3, see what I will do. First of all, I will redistribute prefixes on router number 3. Config T router EIGRP ES number. What ES number I am running? 2 so protocol. So IP protocol ES number 10. Fine. So router EIGRP ES number 10. I can say default metric. Now K1 bandwidth. Let's say this one should be the bandwidth. Delay should be 100, like real interface delay. Reliability is 255, and then it's asking for load. So load is, let's say again 255 or 100. Then it's asking for MTU 1500 byte. Fine. I have now when I will redistribute OSPF for RIP, I don't need to define now k values. right? Like simply now I can say redistribute rip, that's it. On router number 1 you can check the routing table. So IP route EIGRP. Now it is receiving external prefixes. Okay, like this. On router number 3 we can say redistribute OSPF process 1. That's it. On router number 1 we can see 70s prefix also now, right? Correct guys. Now this is routing table of R1. 50 prefixes are there, 60s 70s prefixes are there. Okay, are you guys able to differentiate the prefixes of RIP domain and OSPF domain here? No,
I
because
cannot.
both, yes, we cannot. So we can check one more thing. EIGRP maintain topology table. So let me check topology table. So IP EIGRP topology. Inside the topology table, is there any difference between 50 prefix, this prefix, and where is 70s prefix? Yes, this prefix. No. Right. Both have RD, FD, one successor, and next hop only. But if you will open any prefix in detail, like so IP EIGRP topology and 50.1.1.0 subnet mask 255.255.255.0. Let me open this prefix in detail. Here we are able to see external protocol is RIP. And for 70 prefix, let me check 70 also. 70.1.1.0/24. 70.1.1.0 is not available in the table. How it's possible? 70.1.2.2.0. Okay. Oh, OSPF have different mechanism. This is 70.1.1.1. OSPF is advertising IP address instead of advertising network of loopback. So see 70.1.1.1 not in table. 70.1.1.1 70.1. Oh, actually I was defining wrong subnet mask. External protocol is OSPF. But it is not possible, right? It is difficult to checking source of prefixes one by one, or by providing the network ID to open the prefix in detail, right?
What
So
is
here should be some difference.
external
Yeah.
metric is 3? What that means? External metric is 3.
Okay, don't worry, we'll discuss. Okay. So what we can do here, while redistribution, I can add some values like tag values. Okay, so like on router number 3, let me show you how. Route map name is, let's say, rip tag permit with permit statement. and then we can say set tag. Set tag. Let me set tag number 10. With the help of route map, this time I have used route map to set tag number. Correct. And now while redistribution, when I will redistribute rip prefixes in EAGRP, I will call this route map. Okay. So router EAGRP S number 10 redistribute rip. First of all, I am going to remove this command and redistribute rip and route map. Name of route map was this one. Right. Now you can see the R1 topology table. So IP EAGRP topology with all prefixes of rip domain, we have one tag number. For all 50 prefixes, you can see there is one tag. Tag number 10, tag number 10, right? Tag number 10. Like this, I can create one more route map for OSPF. I can create one more route map. What will be the command? Route map. Yes, can anyone tell me the command, guys? What command I will run to create another route map to set tag number 20?
The tag name.
Tag name. Okay, let's say OSPF tag. Then
And permit.
very good. Here
Set tag 20.
set tag 20. Now router
EAGRP 10.
10. First no redistribute OSPF process 1, then redistribute OSPF
Route map.
process 1 and route map OSPF
tag.
tag. And now on router number 1, if you will check again topology table, you can see the tag number with 50 prefixes and tag number with 70 prefixes. And let's say I want to add tag number with some specific prefixes, like for these three prefixes. For these three in RIP domain, we have two department. Let's say this is department 1 and this is department 2. I want to add tag number 10 for department 1 and tag number 10 and tag number 20 for department 2. Can you guys configure route map for this task? Here, getting my point. What I want, my task is very simple. When router 3 will advertise RIP prefixes in EAGRP domain, it should advertise tag number 10 with these three prefixes and tag number 20 for these three prefixes. Tag number 10 for upper two prefixes and tag number 20 for lower three prefixes. Can you guys configure it? Yes or no? So IP EAGRP topology. This is the first command to check topology table. Now I want to open only RIP domain prefixes. So IP EAGRP topology and then we can say include tag 10. It will include tag
Tag is 10.
okay, like this. Tag 10. Tag is 10. Okay, so like this also we can check topology table. If I want to find the prefixes with tag number 10 or prefixes with tag number 20, right? So all 70s prefixes are here, all 50s prefixes are here, right? So this is simple. This is again basic redistribution, right? Adding this is just adding tag number while redistribution. Now how you will add different tag number for these two prefixes and different tag number for these three prefixes. If I want to differentiate the prefixes which is coming from RIP domain, can you guys achieve it, or can anyone tell me the command process on R3? Config T router EAGRP s number 10 do so run section EAGRP. First of all, I am going to remove this command. This command also. Now R1 is not receiving any prefix from RIP of external prefixes, not any external prefixes. Now on router number 3, what I can do, first of all, let me remove route map also so that I can configure it from the beginning. No route map, tag RIP. Tag RIP do so route map RIP tag. No RIP tag. Fine, and OSPF tag also. Today mouse is not working fine. Okay, now first of all I can do what, I can create one access control list. Let's say access control list number 1 and permit. I can first make interesting traffic. What will be the summary address of upper 3 network? 50.1. Let's say upper 3 network, 10 1.0 2.0 3.0
22.
0.0 subnet mask wildcard mask 0.0 3.255. Yes or no? And see, I am creating access control list with permit statement, right? And for lower 2 networks, what will be the summary address? For lower 2 network, what will be the summary address? For 4.0
Slash 23, then it should be 1.25. Yeah.
254 na means wildcard
No,
mask is
0.0.1.25.
very good. Good. And now I will create route map. Route map name is, let's say, RIP tag permit sequence number 10. First I am going to say match IP address from access list number 1. First it will match the IP address from access list number 1. So in access list number 1, here this is access list 2 now. This one should be the 2, access list 2. Okay, I am giving you overview. You guys can configure it by yourself also. It is very easy, right? This access list should be 2, not 1, because here we need to create 2 access lists, one for upper 3 prefixes and one for lower 2 prefixes. So here in first route map you will say match IP address from access list number 1, and then you will set tag, let's say 101, set tag 101. Fine. And after that again route map rip tag permit 20, and then match IP address from access list number 2, and then set tag, let's say 102. Tomorrow I will perform this lab again otherwise. Fine, that's it. Now you need to call it in EIGRP, router EIGRP S number 10, and redistribute rip route map rip tag, and that's it. Now if you will see on router number 1, you will see router number 1 topology table. So IP route EIGRP 4. So IP route EIGRP, what happened here? Redistribute rip route map rip tag, do so route map match IP address from access list 1, that is perfect. Match access list with 20, do so access list 10 50.1.
I guess wildcard bit is wrong.
Here this wildcard is correct, na? 50 dot for upper 3 network 0.0.3.255. I think this one is correct.
Access list
Oh,
is 1 to
22.
2.
Okay. I'm going to create both access list 1 also and 2 also. Access list 1 permit, tell me the summary address 50.1.0.0 0.0.3.255. According to me this wildcard mask is correct. Am I right?
Okay, sir.
Access list 1, sorry 2 permit 50.1.4.0 and wildcard mask is 0.0.1.255. I think this wildcard mask is also correct. So IP access list. Now we have 2 access control list, and so route map match is not there, right? Match is not there. Match classes IP access list 1, that is perfect here. Route map is correct. Now let me check routing table of R1 again once. Yes, still same. So IP EIGRP neighbor, yeah, neighborship is fine. So IP EIGRP topology This router have also not received. We have installed these 50 prefixes in table, in AGRP table, means redistribution is not working. So IP protocol AGRPS number is 10, right? Yes. So run section AGRP router AGRP10 default metric. Okay. Redistribute OSPF 1 route map OSPF tag. I had removed this command. Wait guys, 1 minute, let me check why it's not working. I will perform this lab tomorrow. Okay, just wait. But yes, now it have installed all prefixes of, I think, OSPF and RIP. All 50 prefixes. Still 70 prefixes are not. It is receiving prefixes from RIP in topology table. Router PAGRP is number 10. Redistribute RIP route map. What was the name of route map? Do so route map. Name of route map. Oh, name was like this. RIP tag. So route map sorry, redistribute, rip, route map, and this one. Now you can check R1. This is the correct configuration, right? So IP EAGRP topology. For upper three prefixes, you can see tag is 101. So like this, for lower prefixes, for OSPF prefixes, you can add tag, and we can check topology table of for RIP prefixes also, for OSPF prefixes also, for a static route also, correct? So IP EAGRP topology, as I told you, include tag is 101. So these three prefixes are coming with tag number 101. So in one routing domain also we can differentiate the prefixes. Now we have default route propagation in EIGRP, and route filtering is done here, redistribution is also done here. We can perform some more lab of redistribution, like we can use tag number for some prefixes, different tag for some prefixes, but concept is like we cover all the concept which we need to understood. Understood, guys? Understood. The route filtering, default route propagation, we can cover it in OSPF also, but here also